Hello, welcome to the session entitled Nailing Down Bugs in Distributed Systems. My name is Kamil Szymański. I'm a tech lead at Pragmatic Coders, and what I would like to share today is to show you how having a well-designed process for detecting bugs in our software systems, live systems, presumably distributed, and then also having a process for getting rid of those bugs out of the system in a quick and safe way can make your lives easier, your job more pleasant, for sure less stressful. And the session I'm gonna do today will be a live demo session. It will roughly consist of 3 interleaved parts. In the first part, we're gonna introduce some tooling, just to be on the same page, because some of the tools you might know, some might be new, but I would really like all of us to get a feeling what those tools are and how we can use them, because later on we're gonna combine data from those tools into a unified process for detecting and handling bugs. And finally, we're gonna talk about how to build a process that allows us to safely get rid of those bugs and quickly. So, since this is gonna be a live coding session, let me get rid of the slides and describe you a bit context we're gonna move around today. So, let's imagine that we are working for an e-commerce shop, a relatively young one, but a successful one, and innovative one that was able to grab a really impressive bite of the market share, despite not having English version of the website, despite not having banners, carousels, or all the other stuff that we think are common and necessary for the e-commerce shop, because we are innovative. Like we have, for example, features like same-day delivery guarantees, like drones, wide area of logistic partners, things like that. And because this is a really tight market, there's a constant fight for each order, each customer. The last thing we would like to experience is start losing what we put so much effort into gaining. So losing market share or losing reputation, clients, having the money flow impacted. And the number one thing for suffering those things would most probably be bugs. And bugs are usually related to code changes. And we wouldn't like to prevent bugs by not making any changes. We want to stay innovative. And if we learned anything as an industry, is that there is no such thing as a system without bugs. Basically, anything bigger or more complex than a hello world will contain bugs. Some of them, of course, we can live with for days or even months. With others, like we can quickly render ourselves out of the business because they are too costly. So if we cannot eliminate bugs by not doing any changes, we want to move on the other side. And the only thing that I know of that can allow us to mitigate the costs of bugs, at least that is possible and not costly and affordable for us, is to be able to react quickly. So what we want to do is to be able to detect the bug as quickly as possible and get rid of it as quickly as possible if necessary, so that the smallest amount of customers is impacted, so that we don't lose reputation customers, or if we do, it's really limited in the costs of or consequences that we suffer. And if you want to detect bugs as quickly as possible, then we should be able to grab some data. And the first place where a bug will probably manifest itself are logs. And nowadays, I would say it's a common thing to have in our services a centralized logging system, things like, for example, the Elastic Stack, Kibana, that allows us to stream logs into a single place, be able to then search through them, find what we are looking for. But I would argue that this is not the best place to check whether there are any errors in our system. Of course, we can strive for creating more visual graphs, like we would color this. If there are a lot of debug logs, it will be all green. If there are an error, there will be a red part somewhere here. But this doesn't offer us enough context, because if you, for example, look if there are any errors here, let me refresh. Okay, I know what it is. I was a bit too fast, because I didn't merge a pull request that is supposed to introduce a bug into the system. So let me do that. This is a pull request that introduces a bug. It's like not a trivial bug, because it's in the asynchronous flow, just to make it a bit more interesting. It's related to third-party provider, but nevertheless, those are slides, I guess. But nevertheless, if we try to search for errors here, if we find something here, it doesn't say us much, because it might be a bug that we used to live with on production. I know that this sounds not so good, but at least my experiences are that in most systems there are bugs that we just used to live. We're using software, we don't third-party libraries, there are things that just pop up here, or things are logged on wrong severity levels, like if, for example, SSL certificates expire, this is clearly a huge error. But if someone tries to sign in and inputs an email address that doesn't match the email address pattern, this isn't a crucial bug. Like, this shouldn't be logged on the same severity level. And like, if we have a plethora of entries here, it doesn't say whether there's a plethora of bugs or there's a plethora of entries connected to the single bug. And if there are no entries here, it doesn't say that there are no bugs in the system. Maybe the bogus functionality wasn't yet reached by the customers. So what I tend to do in my systems is to introduce another software for aggregating logs, but it does it for a different reason, different purpose, and in a slightly different way. So an example of such a software would be Sentry. And to the Sentry, I send all of the logs on the error severity or error and warning severity if I need to. And Sentry aggregates it in a way that each bug has, or each code path that leads to some kind of an error bug has just one entry here. So even if I logged 20 log messages related to the same code path, I will have a single entry here. Of course, I can resolve them, so try to do the zero inbox policy. I can assign it to myself, but the best part of it is that whenever there's something new here, something new happens in our system, I can be notified on my favorite notification channel. So I can integrate it with email, SMS, Slack, HipChat, whatever channel I check in the near real time, so that whenever the bug is, a new bug enters the system, I am quickly notified about it. I do not have to watch all the time the graphs that we have here, or run any queries that check whether there is an error in a system, and then it would require me to check whether this is a new error, or if there are no errors, rerun the query after some time. I will I'm asynchronously notified about this stuff. Of course, there's also context attached to that, so I can tell what the stack trace is, and a plethora of metadata attached here. I can see where the bug first happened, how many times it was seen, and a couple of more important data. But knowing that the bug is here doesn't easily allow me to get rid of it, because I don't know what the bug is. And this tool can give me enough context if the bug is super simple. But if the bug is more tricky, like in this part, it's in asynchronous call, I won't find the answer here. But if we add to that tracing data, then we can connect all the interactions that users are making and be able to go step by step into what happened and try to figure out what is the root cause of the bug. And if we are using a tool like, for example, Spring Cloud Sleuth, we get this out of the box. And this tracing data looks like that, that whenever any interaction enters the system, it's assigned a unique identifier, and this identifier is propagated throughout the whole system. So if I hit, for example, the web application service, the new identifier is generated, and if this web service, to fulfill my request, needs to go to the customer service or to the database or somewhere else, this identifier is propagated through all of those systems. So what we can do to show that is to show what is the service that was contacted, and also what are those trace IDs. In the nomenclature, you can also find it by the name of correlation ID. So all of those log entries are related to the single interaction that entered the system. But as you can see, there is a lot of entries here, like almost 300, which is a lot, or not a lot. It depends on how many things you are logging. But nevertheless, it touches a lot of services like recommendation, order, shipping, customer, payment, web, and a couple of others. So to find what is the root cause of it wouldn't be that trivial. Most probably, if it involves an asynchronous calls, then part of those log messages are not on the path that led to the error. So it would be pure noise for us. It would be like finding a needle in a haystack. So we should try to limit the scope of the analysis that we need to make to find out what is the root cause. And for that, we can use another identifier, which is in tracing nomenclature called span ID. And span ID is an identifier that is generated each time a logical context of execution changes. So by default, in most implementation, it will be when there's a service changing that executes this action. So whenever we make an HTTP call, we will generate a new span ID. Whenever we send a message to the broker, we will generate a span ID. But we can control that. So whenever anything important happens within our application, whenever, for example, we change the thread that is processing the action, we can generate a span ID. And let me show you that in Kibana, and in a minute we will visualize it in a far better way. So if we show span IDs here, you can see that the whole interaction, it has the same trace ID, but the span ID changes every now and then. So Like here, we are touching recommendation service, and we have a single span ID. Then we are going to the order service, and for the sorry, what happened? For the small part of it, we have one span ID, then the other within the same service. And using those two IDs, we can try to visualize what is happening there. And okay, demo guts are not with me, but let me do it this way. So we can visualize it by okay, I know what happened. Yeah, we searched for span, not the trace. Sorry for that. Wrong identifier to search for. So this is a visualization of the interaction that is taking place. And the tool that is doing that, it's Zipkin. It's one of the tools for that. It's using this data span IDs, trace IDs, and based on that, it creates this acyclic graph. Zipkin is usually used to allow you to fix performance problems, find bottlenecks, because how long the bar is means how much time it took. So if you want to optimize something, you know that, for example, you should focus on this synchronous flow probably, because here there's not much room for the gaining in terms of performance. But it's not the only thing that you can use Zipkin for. And if I need to find the root cause of a bug, I use Zipkin in a bit other way. But before we get into that, let me show you how Zipkin is creating this graph. So if we click on any of those bars, we can see like the timings when the request was received, processed, response sent, and so on and so forth. So what was the method, like whether it was HTTP or some other protocol, what was the path. But more interesting data is here. It basically says what is the trace ID. So trace ID is the whole image here, like this whole graph. And span ID is a single bar here. And apart from trace ID and span ID, each time we also send a parent ID, which is a parent span. And hence, we are able to create this graph or tree, if you wish. And to help ourselves to find the root cause of this issue, what we need to do is just to try to reach the place where the bug manifested itself using the shortest path, or there should be just a single path that led to this error. And what we can tell is that this error happened in a recommendation service. It's related to some kind of Facebook recommendations. And if we wish, we can also check the span ID. So this should be this one. Let's check it for sure. And yeah, it is this one. So what we want to reach is this place. So what I usually do is I collapse the whole graph, and then I expand, trying to reach this place where the bug is manifesting itself. So we know that the order service was touched, the web server, the order service, then another part of the order service, and then we go into recommendation. And what it says to us is that during our analysis, we can completely omit, for example, customer service or payment service. They are not on the path that led to that error. And even if, for example, the order service is huge, we can clearly say which parts of the order service we should evaluate. And it's not that we should analyze it all at the same time. We should start in the smallest context that is possible here. So what we should do is start from that place, if the error is not here, we should move upwards. So we analyze recommendation service, and if the error is not here, or rather the root cause of this error is not here, we move upwards. So we move to the order API. How does it look like? We just copy span IDs. So if we want to do that using logs, we just need to search here for span IDs, and yeah, usually they are not so unique, so we need to be a bit more specific what we are trying to search here. So we need to explicitly say that we are looking for span IDs. And instead of 300 entries to analyze, we have only 5 of them. And it allows us to not dive into parts that are not related, not on the path that led to that error. But I won't say that this is easy, and it will allow you to quickly find out what is the root cause, and you will be able to get rid of the error in a minute. It might be so, it might take time. And the time is crucial here, because we've said that with some bugs, the longer they are present in the system, the less credibility we have on the market, the more unhappy customers we have, the more our income can be impacted. So we don't want to dive into this whole exercise of like limiting the context if the bug is really severe. In that situation, what we need to do is as quickly as possible remove the bug. Not fix the bug, but remove it from the system. Like if it's just a small inconvenience, we can do it this way, try to find out the root cause and fix it. If the bug is severe, we don't have time for it. And to quickly tell whether we are dealing with that bug or the other category of bug, it's not that we need to know the whole system and be able to tell that whether if there's some issue with a binary protocol signature, this is a critical thing or not. We need something that tells us whether we should remove it or we can wait and fix it and continue developing whatever we are developing. And for that, we need to measure some kind of KPIs, key performance indicators or metrics, if you wish. And for that, we can use a tool like, for example, Grafana with Graphite under the hood, or Prometheus, InfluxDB, whatever you prefer. The crucial part is to measure those KPIs, and not only technical ones, whether the CPU is fully utilized, whether we are running out of the memory, but most importantly, the most crucial business metrics. And in our systems, those recommendations are not the recommendations that we usually find on e-commerce shops. Like if I bought a refrigerator, I might be also interested in a microwave because other customers bought it or something like that. In our innovative system, those recommendations are sent through different channels, like through Facebook, Twitter, Google, and so on. And we monitor what channel we receive orders. And you can see that when when Facebook recommendation started misbehaving, we lost like 40% of the whole orders coming to our system. So this is a really severe bug. We shouldn't try to fix it. What we need to do is, as quickly as possible, get rid of it from the production system. And if we want to get rid of it from the production system, we should be able to do that in a fully automated manner, because this is a stressful situation. So it's super easy to make a mistake. And hence, we usually have deployment pipelines for that. This is just an example Like what you have seen, there was a plethora of services that was touched by this interaction. This shouldn't be how it's working in the real life. There should be just a couple of services handling each interaction. And here we have the opposite situation. Usually those deployment pipelines are a bit more advanced than this one. This is a really basic one. We just build a service. When we trigger the pipeline, we build the service, scan it for some vulnerabilities, then we deploy it on development environment, run smoke tests, acceptance tests, then we move to the test environment and to the production. And I don't know how long acceptance tests, for example, are taking in your cases. Whose acceptance tests are able to run faster than 1 hour? Okay, just a couple of hands. I assume that everyone has an acceptance test suite. So 1 hour is a lot. So if we are dealing with such a situation, like during 1 hour, we're losing a plethora of money. This can really impact our business. And moreover, we can lose a lot of customers. We can lose a lot of reputation even. So we should make it a bit quicker. If assuming that acceptance tests take 1 hour, fixing the bug or even trying to remove it can reach production as soon as 1 hour for acceptance tests, plus time for the other steps in our pipeline. The fastest way to get rid of the bug would be just to revert the commit. Of course, if we are deploying pretty often, because if we do large scope deployments, it might not be that easy. But assuming that we are doing that, it's still 1 hour plus that we cannot afford for that 1 hour. So what would you say that if for this reverting of that commit, we would just skip acceptance tests? We would only execute the other steps. It's just the mind exercise. I want you to think for a second about that, and I will drink. So fortunately, no one thought about it as being a good idea, because it's, I would say, the worst idea that we can have. And unfortunately, this is the first idea that usually pops into our minds. And in situations like that, we shouldn't skip any tests, because this is a really stressful situation. And in such situations, we usually do stupid things, stupid mistakes that we wouldn't have done in normal situations. Like, even if we just revert the commit, it can happen that, for example, we reverted the commit plus pushed to the repository our local changes because we haven't checked that, or we weren't on the master branch, or whatever, or someone did a git minus force. Yeah?
Why not just deploy an release that's already tested?
Okay, so I'm reaching that place. In a second, I will discuss it. So the first and the most important thing here is not to skip any kind of test, because we can end up in a situation where we not only haven't get rid of the bug from the production system, but we might also introduce a couple of new ones. So this is not the way to go. And the other thing that we usually try to do is just to redeploy the previous version of the system. So just trigger the previous working version and redeploy it. And this won't take 1 hour plus. It will be usually a couple of seconds up to minutes, or it should be. And this usually works. It works most of the time, but not often, not always, because we are deploying the version of the system that was working, but we are deploying it to the environment that might have had changed in the meantime. Like for example, we can do as part of the deployment a DB migration, for example. So if we had a breaking change doing that migration here, if we try to redeploy the previous version of the system, we not only have a system in a state where one of the most important channels is not working here, we can render ourselves with the system that is unable to boot up. So instead of not having just 30% of our traffic, we would end up with having 0 orders because the system won't be working at all. So the solution I would like to propose is to slightly modify this pipeline. Let me just regenerate it. Sorry, I have to merge code, change. Oh. Okay, and regenerate it once more because I forgot to push changes. By the way, like if you are creating deployment pipelines, try to do that via code. So keep it as code. There's a plethora of solutions for that. If you are using TeamCity, there will be something for that. If you are using Bamboo, there should be something else. I like Jenkins. So for Jenkins, there is a pipeline plugin for Jenkins 2. There is also Jenkins Job DSL, which is a fantastic plugin that allows you to script your pipelines, keep them as code. So in a second, we will see a regenerated version of the pipeline. And this version adds a couple of steps into our pipeline. So any change will take a bit longer to reach the production. So this is not a perfect situation, but this is a trade-off and a really important one because although we are, it's taking us longer to reach production, we are gaining a lot of confidence in any change happening. Because the steps that we've added to our pipeline are related to testing rollback procedures. So what we are doing right now on development environment, instead of just deploying the newest version of the service, smoke testing it, and acceptance testing it, we have 4 more steps here. What we are doing is we're deploying the new version of the service. We're running smoke tests just to confirm whether it works, like the most critical path. And then we are rolling back to the previous version of the system. So what we are verifying is that we can roll back on production if it's needed. It shouldn't be needed often, but if it's needed, it needs to be tested. We need to be 100% sure that it will work. If we roll back, we smoke test it, and then we redeploy the new version of our service, so that if we want to roll forward, we are sure that we are able to do that. And then we smoke test it, acceptance test it, and so on and so forth. And after we've done so, what we can do if there is a bug on production, we just trigger the rollback procedure. And it takes us the same amount of time as we would just try to redeploy the previous version, but there is a huge difference in the confidence that we have by issuing that action. We know that we can roll back and we will be able to roll forward. So whenever there's a critical bug, the one that we can spot on the KPIs, we can just roll it back and then safely on development environment, test environment, or any other, try to reproduce this bug, try to fix it, but the system is back to the previous state. So instead of not having those 30% of the traffic in our system, we are back to the full 100% of the orders that were reaching our system. And of course, this is just an example. It's not the only solution. Like there are Canary releases, Bluegreen deployments. We can use things like feature toggles there. The most important part here is that this should be part of the deployment pipeline, and this should be tested. Because even if we go with blue-green deployments and we keep the running version of old environment, there will probably be some part of the system that is shared, like for example a database, a relational database, that if we don't test for rollbacks, we can render ourselves unable to bring back the blue version of the system if there is a backwards incompatible change. And having that inside the pipeline, it will also allow us not to do breaking changes, or rather to break those breaking changes into a set of changes that between each other are compatible. Because any breaking change can be splitted into a set of changes that are compatible between themselves. So if you are, for example, to rename a column in database, you don't just rename it. First of all, you create a column with a new name, then you are pushing data to both of those columns, then you remove the old one, for example. So instead of doing this in one go, you split it into a couple of steps that are backwards compatible between each other. Of course, if we have that, this doesn't mean that we can roll back like to the beginning of the time. The test that we are doing here is only that we are able to roll back to the previous version of the system. It doesn't mean that I will be able to roll back to the previous one and then from this one to the previous one and so on and so forth. Like we really need to narrow it down because otherwise it's really costly and it can render ourselves unable to do any breaking changes or severely impact the time to market. And having said that this can be automated, it's not the only way to automate it. Like it doesn't say that it requires me, for example, to click the button that starts the rollback. We can go even a bit further. So for KPIs, as we had for logs, we can also define some other alerting mechanisms. So what we could do, for example, is to define some thresholds that whenever, for example, the amount of orders that are entering the system drops too low, or if like the number of customers leaving the sign-up process rises too high, we can add an alert here and be notified over email, HipChat, Slack, whatever notification channel we prefer. And there is even a thing that we can move further. I'm not yet ready to do that in my systems, but whenever there is an alert on KPIs, we could, for example, execute a webhook that automatically triggers the rollback procedure. I'm not yet ready for that in my systems because it doesn't always matter that the change is problematic. It might be that, for example, some certificates expired or the third-party provider went down. So this is not yet a thing for me, but I think that there is a huge potential for such things in the future, and I believe that in a couple of years or in a decade, it will be part of the like normal part of the pipelines that we are creating. And yeah, this is what I had for you. If you have any questions, I will happily answer them. So, are there any questions? Yep. Okay, so the question was about Zipkin and whether this goes into the Elastic stack. The centralized logging facilities that we usually have, they not only collect logs in the single place, but they also tokenize them. And like, let me find some. They tokenize stuff. They take the whole logging message, and what we can see here, those span IDs, trace IDs, and so on and so forth, those are part of the message that is being logged. Of course, we do not log it by hand, saying that log the message X, span ID, Y, service named, order, and so on and so forth. It's a cross-cutting concern. So for example, if you are using Spring, there's a fantastic project, Spring Cloud Sleuth, that does it automatically for you. It just adds those spans into the logging pattern, and tools like Logstash, Logstash tokenizes. They can tokenize it. So this data is all part of the logged message. So it ends up in Elasticsearch. Hence, we can see it here. But Zipkin doesn't use Elasticsearch. It has its own database that is optimized for that use case. So you can keep it in the relational database. You can keep it in Cassandra, for example. There's a plethora of options. Like, I won't say that this is something you will take for granted. The bigger traffic you have, the more services you have, the more work there will be on the infrastructure side. So you need to have a good engineering team because this needs to be like maintained. It needs to be bootstrapped. So there's a bit of an effort, but it's really worthwhile. Nowadays, I wouldn't risk going into production not having those observability features. Of course, depending on what you are deploying into the production, because if you are deploying a service that just, I don't know, displays pop-ups and you don't have many paying clients or something like that, you are not trying to like expand on the market, it might be okay to just have a service and like be able to log into cloud and look for logs. But if you are doing something really business critical, I wouldn't go into production not having all of those capabilities. And the most important ones are monitoring and deployment pipelines, in my opinion. Does this answer your question? To Zipkin, so in Spring Cloud Sleuth, like all of those spans and traces are added to the queue, and whenever this queue gets full or whenever there's a timeout reached, all of those data is pushed to the Zipkin collector. So this happens under the hood. There's a thread running that check whether the queue is full or like whether the time span was reached, and it pushes the data. But it happens without your intervention. It works under out of the box. Yep. So, so if migration is part of the deployment, if the migration is not backwards compatible, you won't be able to roll back, like the smoke tests will fail. If everything is okay, you will be most probably able to roll back and roll forward. Like there are, if you're working in a Java land, I guess you do, there are two fantastic projects. One is Liquid-based that allows us to script database migration. The other is Flyway. And Liquid-based allows you to create rollback migration procedures. Although I would say that instead of investing into those rollbacks, we should invest more into testing that, and we should only roll forward. But if you need to do rollbacks, then go ahead. Does this answer your question?
Yeah, I guess.
More or less.
Smart if you could, in the rollback, save the extra data you're removing by rolling back.
So that's why I mentioned if you don't go into this rolling back, but if you need, go ahead, because like if you are creating a new column, you are pushing some, storing that data, some data in that column. If you remove it, you lose you lose this data. It might be okay to lose it. It might be that this data was important and you lost really valuable data to be processed by business, for example. So it all depends on the context. I would say that usually you shouldn't have those rollbacks procedures, but if you evaluate it and if you find that this is okay in your context, then yeah, go ahead. But the evaluation part is crucial here. Okay, are there any other questions? Okay, so lastly, I can show you why those rollback tests are necessary here. Because a couple of times I was asked, like, is it worthwhile to do all of those things? Because during each of the releases, we run a large acceptance test suite. It's all automated. It's not super fast, but it's like testing everything. And it's not testing everything. It's usually really long if we try to do that. So instead, we should only test the most critical parts of the system, and the rest should be part of the monitoring. And testing things automatically doesn't say that everything will work. So this is the website. It's in Polish, but I guess you can pretty much tell what's happening here. We have here a buy button. And if we test the buy or order flow, it will work even if we do one small change in CSS. So if we change a single thing in a CSS, everything will work because the button is here. It's just that the button is white on the white background with the white font on it. So although the automated test will be able to go through that flow, normal users won't be able to do that. They will never click here because they won't see that. So to summarize what we have talked about, invest a lot into the processes for dealing with, for detecting bugs, that allows you to quickly and safely get rid of those bugs, and invest into observability facilities that will allow you to easily tell whether you should, as fast as possible, get rid of the bug, like get back to the previous state of the system, or is it just a small inconvenience? Like there are errors in logs, but yeah, clients are more or less happy they are able to execute actions that they are taking, so we can leave it on production and deal with it tomorrow, maybe. So invest into those tools, invest into processes, think a lot of about those processes, and have a less stressful and more pleasant work due to that. I hope you enjoyed this session, and I wish you the great rest of the conference. Thank you.